Welcome to the 82nd ESA Parabolic Flight Campaign, but this really is one with a difference. We don't have any ESA experiments on board. This is all NASA experiments for their human research project. We have 5 experiments on board. They're all biomedical, looking at different ways that the human body reacts to zero-G. Today we have a zero-G flight. We've just entered a parabola now. The other 3 flights on this campaign are all going to be partial G, with 1/4 gravity, 1/2 gravity, and 3/4 gravity. So we really have quite a variety of gravity levels, a variety of things to do, and a lot of test subjects on board. You'll see the plane is a little bit emptier than usual. That's because we needed to fit all the people on board. The seats are the bottleneck this time, but it's going to be very challenging, very interesting. Let me give you a tour. So this experiment is looking at optical alignment. This is really fundamental physiology. Normally our brains keep our eyes aligned because of the visual cues that we have in our environment and also our gravitational cues. So here, of course, we're removing the gravitational cues, and the visual cues are only controlled by these visors, by these headsets, and we're perturbing the alignment that they can see. They have to try to line things back up, both vertically like this and also rotationally, to see how our brain's ability to align our eyes changes with the different gravity levels. So this experiment is looking at bimanual coordination. So it may not look like they're moving very much, but they are pressing down with their arms on these sensors, and they have to press in kind of polyrhythmic patterns, sometimes in phase and sometimes out of phase, with their different hands doing different things. This is changed, your ability to do this is changed in partial gravity, but they are also testing some type of medication that may perturb these people in this task, and half of them have a placebo, half of them have the real medication. They don't know which is which. We're going to find out if it makes any difference. So you can see in this part of the plane it's rather dark. That's because in these experiments they really need to be able to focus on what they're doing on the screens, not be distracted by light cues around them. This particular experiment, this is an ultrasound experiment looking at blood flow in jugular veins, because we've seen with astronauts from the ISS, sometimes they have a reduced blood flow in these veins, sometimes even reversal of blood flow, and could have risk of blood clots and strokes. So trying to understand how that transition happens, in which gravity level that transition happens, so we can try to keep astronauts safe wherever they go in the future. So in longer term spaceflight, one of the problems that we know we're going to have is, for a mission to Mars, for example, there are various mission critical activities that astronauts will have to do in partial gravity that they have to get right the first time, such as connecting to their power source after landing on Mars. We're checking here that astronauts can conduct those functional tasks and finding out what levels of gravity change their ability and adaptation to do so. Here, of course, we're just trying the zero-G with the simulation of catching the HTV with the Canadarm on the ISS. It's an analog for what we might do later. So one of the special things on this campaign is we're not just doing zero-G, we're doing partial G as well. We're testing things in 3/4 gravity, in 1/2 gravity, and today we're testing in 1/4 gravity, which is great fun. It's a little bit more than Moon, it's a little bit less than Mars, it's somewhere in between, but this is great for the scientists to fill in their points on the graph, to find out where the thresholds are, where their regime changes. It's going to be fantastic science, and it's a lot of fun too. So this experiment is looking at high-level functional tasks, not just the low-level senses and motor control, but integrated. So we do these tests with astronauts after they come back from space, for example, and here we can try them in all of these different gravity levels. They have to get up, jump over this obstacle, run around that cone, come back and sit down. Over here, they have to get up from a lying position to standing. And here they are testing their sense of balance with eyes open, with eyes closed, and seeing what the differences are. And here we find the thresholds at which astronauts will or will not be able to do these tasks reliably.